Hey everyone. All right, so some more harder financial questions, part three. So only three questions to go, so hopefully it won't be a very long video. Sameep deposits $150,000 into a savings account earning 6% per annum. Let's highlight some things as we go. So it is an investment, so 6%. So it's depositing, so it's going into the bank. That's what gives it away that it's an investment. Compounding monthly for 10 years. He makes no withdrawals or deposits during that time. So no extra repayments or anything like that. All right, so I'm going to read the whole question because I kind of want to see where we're going, and if I can explain things in more detail, that would be good. So SN is the balance of Sameep's investment after N months, right of recurrence relation. As soon as I saw this, I was like, oh, we're so going to have to write a recurrence relation. All right, let's do that soon. What is the value of this account after 10 years? We can do that soon as well. All right, so after 10 years, Sameep withdraws the money and invests a full amount into an annuity. All right, we're introducing an annuity. Who will require this investment to provide monthly withdrawals of this? Okay. What is the minimum annual interest rate required if Sameep's investment is to be exhausted? So that's go to zero after 10 additional years. Okay. So Sameep deposits $150,000 into a savings account. So part A, we're just doing a straightforward recurrence relation. So we can go to our notes. All right, so this is in your summary posters, or we can just go here as well. So this is an example of compound interest investment, which I don't think I've got on here. Oh no. All right. Actually, yes, we do. Yeah. Compound interest geometric growth. So we haven't made any additional payments here. So if we did, we'd just put plus on there as well. Okay, so we've got V0. So in this question, it's S. So we just got to make sure we do that. And the R sometimes gets people muddled up. So remember, R is 1 plus little r, your annual interest rate over 100p, or on your sheet it might say N. That's just the number of compounding periods per year. So let's write the recurrence relation. So we start off with our initial value, which is 150,000. All right, and then we've got SN plus 1 is equal to R. So I'm just going to write what R is. 1 plus our annual interest rate, which is 6 over 100 times the number of compounding periods a year. And I did read monthly, so there it is, times SN, the previous value. Now we're not making any withdrawals or deposits, so we can just leave it like that. Although I do need to simplify my value of R, so I'm just going to do that on my calc. So 1 plus 6 over 1200. So we get 1.005. And you could do times, or you could just write SN. Now I'm going to put a times there just so we don't think that S is a 5. You don't have to write S0 again, all is well. Okay, so there's our recurrence relation. Now, if we did a rule, which we can use for to calculate the next part, is just R to the power of N times our initial value. So for part B, so we're doing S 10 years, so 10 times 12, because it's how many compounding periods you have. Then R, so 1.005 to the power of this 10 times 12 times your initial value. All right, so I just got this straight from this sheet here. All right, Rn times V0. Now, you can just plug all this into your calculator. So we want to find S of 120. All right, so it's going to be 1.005 to the power of 120 times your initial value, and we get 272,909.51. All right, so that's how much it will be worth after 10 years. So quite a high interest amount, not adding any extra repayments, just purely getting the interest. So if we wanted to work out the interest, not that this question asks us, you can just take away the initial deposit and that's how much interest was earned. So $122,909.51 interest over 10 years, which is pretty good. All right, so let's say when you were born, you were gifted $150,000, and then when you were 10, that's how much you get, which is pretty cool. Now, you don't have to use the rule. The rule is one method. You can use Financial Solver because this is just compound interest. So let's do it using Financial Solver because that's probably what majority of people aim to now use. Just remember it's 120 compounding periods. Our interest rate is 6. Our principal value, it is an investment, so it does go in positive. Just make sure you got the right amount of zeros. We're not making any additional payments. So that's just going to be 0, guys. We're going to enter that in. And then 12 and 12. So our future value should be the same amount, right? Which you can see there. All right, so you can use Financial Solver or you can use the rule. I did want to do the rule here just so you can see its application because, you might have to use it one time. So it does exist. The other way you can do it is go to sequence and you can put your recurrence relation in, or you can put your rule in here as well. The only thing is we're doing 120. So if I put my rule in, which is 1.005 to the power of n times 150,000. All right, and tick that and go to my table. So we've got all these values here, but I only go up to 50. And if you've never used this before, you probably only go up to 5. So to change that, we just go to, that button there. So I just had to make sure it was the right one. So the one with the XY with the arrows on it. And you can go up to 150. And then we can go, we know it's around 120. So I can just keep scrolling. Scroll too far, just go back, and there's our amount there as well. Bit hard to see on the actual table, but there's your amount there as well. So 3 ways you could get that answer. If you're asking what one I would use Financial Solver. I'm a huge fan of Financial Solver. All right, so after 10 years, Samir withdraws the money and invests the full amount into an annuity, and he's having withdrawals of $2,600, and now my son's going to come home, which is going to be a bit annoying. Not annoying that he's home, but he'll just interrupt the video. All right, so we're looking for the minimum interest rate. So let's go back to our Financial Solver. Come on. Okay, so we want it to be exhausted after 10 years. So I'm just going to copy and paste this amount in. So copy, oops, no, let's cut it. Sorry, I want to cut you. And paste. Now, paste. All right, we do need it to 2 decimal places. Now, this time it is an annuity, so it goes into the bank and it's positive, so just make sure it's positive. The interest rate is what we're working out because we want it to last for a certain period. So getting $2,600 each time. Oh, sorry, that should be a negative. Did I say it was meant to be positive? Sorry, guys. Can't remember. I'm getting tired. Just getting distracted by my son. Let's blame him. Oops, too many zeros. He's going to come in any minute now. All right. And we want to exhaust it, so it's 0. And there's our interest rate. So 2.7, and what are we doing? 2 decimal places, so 2.72%. There we go. Just want to make sure that's what we had to do. So annual interest rate for 10 additional years. So it's 120 because it's monthly. The interest rate looks good to me. It looks quite low for an annuity, considering we had 6% before. But let me just check everything. So we've got 120. That's our starting amount. So yep, going into the bank. So it is negative. Payments we're receiving 12 and 12. Yeah, looks good to me. Just a very low interest rate. Okay, when Jessica starts working, she sets up an investment account with an initial balance of $1,000. Let's highlight that. Each month she deposits $200 into the account. The account has an annual interest rate of 4.9% compounding monthly. Finds the balance of the investment after 1 year. Oh, that should be easy. How much interest has the investment earned the first year? Okay, round your answer to it. All right. After 3 years, the interest rate increases to 6% and Jessica will increase her monthly deposits to $350. Find the balance after 2 years at the highest interest rate and how many payments of $350 will Jessica need to make to exceed this amount. Okay, so let's do it all on the all on the calculator, and you can just copy it. All right, so let's fill this in as we go. So she's making an initial balance of $1,000. So wrong spot. So negative 1,000. All right, so that's the amount, and she's adding in $200 each time. We've got an interest rate of 4.9. So both of them are negative because the money's in the bank and it's also money still going to the bank, being added to the bank. After 1 year, so she's just doing it monthly, so it's going to be 12. And this is going to be 12. And this is going to be 12. And just to make sure, the only thing we've got blank is our future value. All right, so that's our balance after 1 year. All right, so just over $3,500. How much interest has the investment earned? So we can take this amount, copy it, go into your main screen, paste it, and just take away, now what is it, how much interest? So she's had $1,000 already, and she's also made 12 payments of $200. So we're going to do 12 times 200. So what I've got in brackets is all the money that Jessica has put in. So the difference will be the interest. So she's earned $104.76 in interest. All right, might not seem like much, but this is only 1 year and it's very small amounts to what we've been dealing with previously. All right, after 3 years, the interest rate increases to 6% and Jessica will increase her deposits to $350. So let's go back to Financial Solver. So we've got to round this to 2 decimal places. So I'm going to do that now before I copy it. Or I'm going to cut, and I'll keep, let's clear it. All right, so interest rate has now gone to 6. Her principal value, paste that in. Remember, it's got to be negative because it's still an investment. Okay, and a monthly deposit, she's still making the deposit, but it's increased to $350. All right, she's now doing this for 2 years. So we're going to do 2 times 12, which is 24, and it's still 12 and 12. If it's going to work for us. And so our future value is that. So just under $13,000, which is pretty good. All right, so just make sure you round that to 0.61. All right, 2 decimal places, 0.61. How many payments of $350 will Jessica need to make until her investment first exceeds $35,000? So her future value we want to be $35,000. And that's not $35,000. So everything else is correct. We just want to change the end's going to change. So it has to first exceed. So I don't say it's 71 and I can't say it's 71 and a half because you can't have half a month. So it's going to be 72 months. So 72 months, it will be over 35,000. So let's just have a look. So if I did 71, it's not going to quite be there. So you can see you do need 72 and then it will exceed. Okay, good stuff. All right, last question. Zihan invests $200,000 into a perpetuity from which he will receive regular payment. There are 2 options available. Option A earns this per annum compounding monthly with a monthly regular payment. And second one, compounding annually with a regular annual payment. They're always the same. Calculate the monthly payment from option A, and then we're doing B. All right, so let's have a look at both of them. Now remember, for a perpetuity, your principal value and your future value are the same. For your N, it can be anything, so other than 0, so we're just going to put 1. All right, so for option A, it's 3.6%. We're doing a perpetuity, so it's money going out of our pocket. All right, so negative 200, and I think I need another 0 there, 200,000. Future value is going to be positive that. One more zero. And compounding periods, etc. It's 12 and 12. So it's going to receive $600 per month, which is pretty good. All right, $600 for option A. Now, option B, we have a higher interest amount, so we're going to change that to 3.8. The amount's still the same, all right, but the compounding periods is annually, so we need to change this to 1 and this to 1 as well. So your payment is, so this is a yearly payment, which is $7,600. So remember the other one was monthly and this one is yearly, so $7,600. So which option is better? So if we were doing monthly, you would get $600 for 12 months and you get $7,200. So the other one being $7,600 is the better option by $400. All right, let Zn be the value of the perpetuity after n payments that pays the most over the course of the year. Write down a recurrence relation. All right, so we're going to do a recurrence relation for option B because that was the better of the two. And I'm just going to do this even though it's also on your sheet. So Z0 is your starting amount, so 200,000. Then we have Zn plus 1 is equal to 1 plus your annual interest rate, which is 3.8 over 100. Now we're multiplying that by 1 because it's only one payment period a year, times, I was about to write V, don't get your letters mixed up, Zn. And then we're withdrawing $7,600 each year. So it's minus 7,600. All right, so putting this into your calculator, you will get 1.038 Zn minus 7,600. So this part here is, if we just go back to our financial solver, come from here, all right, your payment. So you're going to get $7,600 each, did I say month before? I meant each year. All right, so that's your yearly payment. All right, I think that is the last question. Good stuff, guys. Bye.